Hello everyone. Yesterday we have seen what do you mean by transform and conquer technique, and one best example for transform and conquer technique, that is heap and heap sort, is it not? Yesterday we have discussed two main types of heap, that is max heap and min heap. Now I'll go for the problem. See here, create max heap for the following elements. These are the array elements they have given. By using this you have to just create the max heap. How to create? You have to first take, see, for example, if the array is given, then very first element will be the root element first. Okay, you have to just take this element in the step. So step 1, first I'll take only the first element, that is 5. This element is done. You just mark the elements or else you'll get confused which element you have taken. Next, step 2. In each and every step you have to take one element, but in step 2 you can have, that is 35, where you have to keep this one. While constructing tree you have to remember, first element you consider as the root element. Next you have to go for left only, you should not go for right. The placement of 35 towards right is wrong. For always you have to place this 35 towards left. So I'll keep this 35, then 25, next element I'll keep to right. Okay, 35 and 25. But here they have asked you to create max heap. What is the condition of max heap? Always the root node should be greater than its children. Here, what is the root node? 5. Is it greater than its children? No. Yes, here what you have to do, you have to make the greater node to come to the root node. How you will do it? See here 35, 25 and 5 are there. Which is maximum here? 35 is maximum. So where is 35? 35 is present here. So swap 5 and then 35. In the second step itself, what you have to do, swap 5 and 35, where 35 comes to 5's place and 5 comes to 35 place. 25 remains as it is. This is the second step. Yes, it is done. Now it is a max heap. Next, I'll go for step 3. In step 3, what you have to do? First you have to write the tree as it is, 35, 5 and then 25, which is the next element you have here, 45. Where you have to place this 45? Again you have to come from left to right. So towards left of 5 I have to place 45. And here straight away I cannot just transfer 45 and 35 here. Step by step you have to do. So what you have to do, see here 35, root node is less than its children because 45 is greater than 35. So what you have to do in this step, first 35 I'll write as it is. In the place of 5 I will write 45. Only one step you have to go. Suddenly 2 steps or 3 steps you cannot go. You have to go one step at a time. Okay, then 5 comes here and 45 goes here. Now, is it satisfying the max heap condition? No, still 45 is greater than 35. So what you have to do? You have to take 45 over here, then you take 35 over here, then 25 and then it is 5. Now step 3 is complete. See, this is satisfying the max heap condition. 45, 35 and 25 are less than 45. Here 5 is there, 35 is greater than 5. So parent nodes are having more value than its children, that is parental dominance. Next, I'll go for step 4, which is the next element to be taken. It is 20. Yes, so where you'll place 20? First write this as it is, 45, 35, 25 and then 5. 20 towards right of this 35. It should be complete. Always you have to come from left to right. Now you see here in step 4, 45 is the root node, 35 and 25 it is less than this one, 35, 5 and 20 is less than this 35. It is satisfying the parental dominance. So step 4, no need to transform anything. Next I'll go for step 5. In step 5 what I'll do, I'll just write the as it is thing, 35, 25, then 5, 20. Which is the next element in array? It is 55. Where you have to keep this 55? Towards left of 55, I have to place this 55. Now you see here. First you check this one from left to right. 35, it is the parent. Children 5 and 20. Parent is greater than 5 and 20. No need to interchange. Now come here. 55 and 25. 55 is greater than 25. So what you have to do? According to parental dominance, 55 should come here, 25 should come here. So I'll do that now. 45, 35, 55 will go here. This remains as it is, 5 and 20. Then 25 will come here. Now you check 35 and 55. Here 45 is there. 55 is greater than 45. So I'll swap 45 and 55. So 55 will go there. 35, 45 will come here. Then 5, 20, 25. Now check 5 and 20 less than 35. 25 is less than 45. Again 35 and 45 is less than 55. Okay, this is fifth step. Now it is satisfying the max heap. Next step 6. What is step 6? We just take it as it is. 55, 35, 45, 5, 20, 25. What is the next element? 25 got over. Next element is 45 again. Okay. Now what you have to do? Again you take 45. Okay. Sorry, here we have taken 55. Next I have to take 25. Is it not? No, I have to take 25 as the next element in step 6. So where I have to place? Here towards left I have to place 25. See here, again the parental dominance, 5 and 20 less than 35, 25 and 25 less than 45, then 35 and 45 less than 55. Step 6 is proper. Next go for step 7. I'll write all these as it is. 5, 20, 25, 25. Which is the next element after 25? It is 45. Now, where you have to take this 45? Again you have to start from left to right. Towards left of 5, I have to take this 45. Now check. 5 is the parent node, but 45 is the children. 45 is less than 5. Is it not? So, again replace that. 55, 35, 45. Then here, in place of 5, 45 should come. In place of 45, 5 should come. Here I'll take 20. Then here, 25. Again, 25. Okay, next here 45, 25, 25, this is satisfying parental dominance, but here 35 and 45, again you need to interchange. 55, in place of 35 you have to write 45, in place of 45 you have to write 35, then 5. Here it is 20, here it is 45, 25, 25. This is step 7. Check. 5 is less than 35. Yes. 35 and 20 less than 45. Yes. 25 and 25 less than 45. Yes. 45 and 45 less than 55. Yes. All the steps are correct. Now I'll go for step 8. In step 8, what you have to do? First write the thing as it is. 55, 45, 45, 25, 25, then 35, 20, here it is 5. Till now we have taken 45, which is the next element. It is 50. You take 50 towards right. I have taken. Now check for the parental dominance. Where I have added here, so you have to check only here. 5, 50 and 35. 35 is less than 50. So what you have to do? You have to construct one more tree, that is 55, 45, 45. In place of 35, you have to write 50. And then this 5 as it is, in place of 50, 35 will come. Okay. So 25, 25. Is it done? Next, I have just placed 50 here. So you have to check with this parent. Which is the parent? 45 is the parent. Is 45 less than, 45 greater than 50? No. Again you have to replace 50 and 45. So I'll take 55. In place of 45, I'll replace 50. Here it is 45. Then in place of 50, I'll write 45. 20, 25, 25. This is 5 and this is 35. This is step 8. Yes, see here. 5 and 35 less than 45. Yes, it is having parental dominance. Then 45, 20 less than 50. Yes. 25, 25. Yes. 50, 45. Yes. 55. So no need to transfer anything. Now we'll go for step 9. Now we'll come for step 9. That is, write the thing as it is. 55, 50, 45. This is the tree what we have gotten. Step 8. So in step 9 I am just writing the same thing. Now which is the next element? Here it is 10. So you have to add 10 over here. Towards left of 20 I'll add 10. Is it eliminating any of the parental dominance? No, because 20 is greater than 10. All these things we have already checked. Here 10 and 20 we need to check. 20 is greater than 10. So no need to change anything. Next go for step 10. Again what you have to do? You just draw all the things as it is. After 10, which is the next element you have to take? That is 30. So here where I have to add, towards right of 20 I need to add this 30. Okay. Yes, I have just added this. Now you just check. Here I have added 30, but what is the parent? It is 20. It is not satisfying the parental dominance. So replace 20, swap 20 and 30. What do you get? 55, 50, 45. Here 45 as it is. Instead of 20, I have to write 30 because you have to swap 20 and 30. Here 20 and 30. So in place of 20, I need to write 30. This 5 remains as it is. This 35 remains as it is. This 10 also. Then in place of 30, you have to write 20. See now, I have replaced 30 here. Check its parent. Its parent is 50. It is greater than 30. So no problem. Step 10 is done. Now go for step 11. Okay, for step 11, write this tree as it is. So here, which is the next element? 15 is the next element. So I have to add 15 over here. Where I need to add? Towards left of 25, I need to add 15. Check the parental dominance. 15, is 15 greater than 25? No, 15 is not greater than 25. So no need to change anything. So here we have done with all the values, is it not? So here, now 15 is not greater than 25. So all the things are satisfying the parental dominance. That is, we are constructing the max heap, not the min heap, max heap. So all the parents should be greater than its children. You check once again. Parent of this is 45, so parent is greater. So for this one, parent is 30, this is greater. For these two, parent is 50, it is greater. For this one, parent is 25, it is greater. So for these two, parent is 45, it is greater. For these two, parent is 55, then it is greater. So this is your final heap tree, what we need to construct. That is max heap, what we have to construct. Okay, in the same way, next for the same values, we'll just construct the min heap. Yes, we have to now create min heap. We have created max heap. In max heap, the root node should be maximum, and here we are creating the min heap. Min heap means always the root node should be minimum than its children. Okay, so I'll take step 1. In step 1, the first node, that is 5, I will take this. Okay, no need to check for anything. Again, step 2. In step 2, what you have to do? 5. Then you have to take the next element, that is 35 towards left, and next element 25 towards right. Now you check. See here, 5 is the parent node, 35 and 5 are the root, children. So what is the condition here for min heap? It should be minimum. Parent node should be minimum. Here 5 is minimum than 35 and 25. So no need to change anything. I'll go for step 3. I'll just retain as it is 5, 35, 25, which is the next element. It is 45. Towards left of 35, I'll insert 45. You just check here, 35 and 45. 35 is minimum than 45. Yes, so no need to change because parent should be minimum than its children. So no need to exchange. Then I'll go for step 4. In step 4, I'll just write this one, 5, 35, 25, 45. Next element is 20. I'll just write 20 towards right. Now what you have to do? You have to just check for parental dominancy. 20 is less than 35. What you have to do? 20 has to come here and 35 has to come here. Swap 20 and 35. So here 5 in place of 35, 20 should come, and here it is 25. Then here 45 it will remain as it is. In place of 20, 35 should come. This is your step 4. Okay, next I'll go for step 5. See, I'll just retain this one as it is, which is the next element. 55 is the next element, where I have to take this one towards left of 25. If I take towards left of 25 means here, check the parental dominance. 25 is minimum than 55. Yes, so retain it as it is. Next, go for step 6. Write this one. Which is the next element? It is 25. here 25 and 25. It is equal, so no need to exchange. You just write it as it is. Okay. Next, go for step 7. Which is the next element you have to consider? It is 45. Again, I will write towards left of 45. I will insert 45. See here again 45 and 45 are equal. I will just keep it as it is. I won't touch that 45 again. Okay. Next, go for step 8. Next, which is next element? That is 50. Where you have to insert 50? See here, towards right of 45, I have to insert 50. So, check for the parental dominance. Is 45 less than 50? Yes, the condition is true. So, min heap, this is the condition. No need to just swap that one. Next, I'll go for step 9. Again, write all the things as it is. Which is the next element? It is 10. So, where I have to insert towards left of this 35, I'll just insert 10. Now check, 35 is greater than 10, but this is not satisfying the parental dominance because this is minimum heap. So, what you have to do? You have to just swap that 10 and 35. So, 20, 25, 45. Here in place of 35, you have to swap 10. Okay. And here 45 remains here only, 50 here. Then in place of 10, you have to get 35. Then here 55 and then 25. Swapped here. For this 45 and 10, which is the parent? 20 is the parent. Parent should always be minimum than its children. So here 10 is minimum. So you have to again replace 20 and 10 in step 9. So 5 in place of 20, I'll write 10. Here 25. Here 45 remains as it is. Here 20 will come. This is 55 and then 25. Then here 45, 50 and then 35. I'll write it as it is. Now you check 5 and 10, 25. 5 is the minimum. No need to change. No need to change anything. Now I'll go for step 10. Still how many elements are there? Still 2 more elements. Next element I have to take it as 30. Before that I'll write this 9th step as it is over here. So after this, here next element I have to take is 30. So 30 towards here, towards left of 20, I have to just insert 30. Check the parental dominance. 30 and 20 is 30 is less than 20? No. So it is satisfying the parental dominance. So no need to change anything. Next I'll go for step 11. Here I'll take 5, 10. Which is the next element to be inserted? It is 15. So towards left of 55, I'll insert 15. See here, 15 and 55. 15 is less than 55. So swap 15 and 55. So I'll just write 5, 10, in place of 55, you have to write 15, then 25, then here this 45 as it is, this 50 as it is, this 35 as it is, 30 as it is, and here in place of 50, I'll write 55. Again check, 15 is less than 25. So again what you have to do, you have to just replace this one. So I'll take 5, 10, then in place of 25 I have to replace 15. So you are swap 15 and 25. 45, 20. Here in place of 15, 25 should come. Again 25. Then here 45. It is 50, 35, 30. Here 55. Now check 15 and 50. Here 5 is less than 15, so no need to change. This is the final min heap. You check now. 45 and 50. 45 is minimum. Equal means it's not a problem. 35, 30. 20 is minimum. Condition is satisfied. 45, 20. Parent is 10. 10 is minimum than these two. Yes. Then 10 and 15. Parent is 5. This is minimum. Yes. Condition satisfied. Again 55. Parent is 25. 25 is minimum. 25 and 25. Parent is 15. 15 is minimum. Yes. This is the min heap. Always remember, in min heap, all the parent nodes should be minimum than its children. In max heap, all the parent nodes should be maximum, means it should contain a maximum value than its parent. This is min heap. In min heap, always the root node will be consisting of the minimum element among all the elements. In max heap, the tree will be consisting of maximum element than of all the elements. See here 55 is maximum than all these, so this is the root node. Here in min, 5 is the minimum than all those things, then this is min heap, which is having, the parent is having minimum value, and this is max heap, that is the parent is having the maximum value. This is with respect to your max heap and min heap. In the next session, I'll just show you how you have to sort the heap. Okay, this is just the construction of heap. Construction of heap using max heap and min heap. Next, we have to see sorting, how you have to sort the heap. Okay, thank you.